Welcome back to Simple Stats for STEM. In this video, we're going to look at a chi-square test, and this is a statistical test, an inferential statistic. It's a very, very simple statistic, and so it's one that is very easy to conduct and is useful for categorical variables. So we're talking about a variable that has a yes or no answer, or it can be one or the other, like male or female. In this scenario that I have here, I'll explain to you what my categorical variable is here. But basically, it deals with grouping or putting people into some kind of a category. And so it's very useful for categorical variables with two or more levels. So I've created a scenario here I'm calling enjoyment of math. So I'm pretending like I've asked students to rate their enjoyment of math, and I've placed them into a couple levels, and they either enjoy math or they find math unenjoyable. And so I've just asked them to kind of raise their hands and tell me if they like math or not. And 39 of them, I observed that they find math to be enjoyable. And 23 of those students found math to be unenjoyable, if you can imagine such a thing. The total of the number of students is 62. And so my null hypothesis, if you will, is that there's no statistically significant difference between the number of students who enjoy math and those who do not. And so I've just really put these students into one of two categories, either enjoying math or not enjoying math. And so that's my categorical variable, and I'm just asking them the question, do you like math or not? Now, 39 of them do enjoy math, 23 say they don't. And the chi-square test is based off of what we would call the expected value. So my null hypothesis is basically saying we're asking the question that there's going to be a difference, or saying there's a difference between students who enjoy or don't enjoy math. So the expected value in that case would be that those two groups would be the exact same. That 31 of them would enjoy math and 31 would find it unenjoyable. It would be a completely matched. So we're saying we don't think that's true, but the expected value, if we're speculating about something here, the expected value would be the equal number like math and an equal number don't like math. That would be split 50-50. So this expectation, or this expected value, is basically just the total divided by the number of groups. And so we just get 31. 31 plus 31 is equal to 62. Now, the math on the chi-square statistic is really very simple, and I've laid out some of the math that we're going to do here. And the first one is to take the observed value and subtract the expected value. And so I'll just do a quick equation for that. I'll hit equals, and I'll click on the observed value minus the expected value for the enjoyment category, and the difference there is 8. Then I'm going to take that difference and I'm going to square it. So I'll just come up here again and I will hit equals. I'll tell it to take this cell and shift 6 for the caret sign, meaning raise it to this power, and it's square it. So I get 64. And then the final step is to take all the steps we've done so far and simply divide by the expected value. So I'm going to take, for this cell, I'm going to hit equals again, and I'm going to tell it to take this value and divide it by the expected value, which is right here. It's 31. And so it gives me this decimal 2.0654 and some change. I'm going to put these both on the right margin just to clean it up a little bit. And so this calculation, this formula, if you will, is going to be based off just this gap between what's observed and what is expected in both of these categories. And so it's really basing this off of a difference here of 8. And there'll be a difference here as well, and then just doing some quick math on it. And so it's really just giving us a statistic that deals with the difference between what was reality, what was observed, and what would have been expected. All right, so we're going to do the same thing down here. Observed minus expected. I'm actually just going to drag this formula down. And down here I'm going to get -8, and that really is just observed minus expected. 23 minus 31 gives us -8. Over here I'm going to drag down the formula as well, and it will do the same thing. It'll take that value and it's going to square it, And so negative 8 squared is still 64. So we're actually getting the same value here. And then when I drag down this formula, it's going to give me the same valuation there. It just so happens that the expected difference from the observed is 8 in both cases. So this gives me same decimals in both of these. Now, what I want to do is I want to sum these two values. So I'll just hit equals and sum, and I'll open parentheses, and I'll click this one, and then comma, and the second one, close the parentheses, and there's the sum. So this is what we would call a chi-square statistic. And that is just the basic answer to a formula. It really is just a mathematical formula, and happens to be 4.12 and some change. And now we're going to do another formula. I've put these up here for a reason, because what I want Google Sheets to do is I want to take this statistic and I want it to tell us if this statistic or this whole scenario is significantly significant. So we want to know if this difference that we're observing is it by chance, or is there something more to it than that? And so this whole scenario could be based on an intervention that I've made in my math classes. Maybe I'm showing one math class videos and the other math class I'm just using lecture method or something like that. So there's some things going on behind the scene, but maybe I'm taking some statistics on that. So I want to know, is there a difference here? So the scenario kind of, there's more to it, but basically this stat is going to tell us if there's a difference, and if it's by chance, or if it's a very small percent that it's just happening randomly. So I'm going to use this a couple of formulas here. On this first one, I'm going to use a formula called chi distribution. So I'm going to start typing that, and it'll pop up here. And this calculates the right-tailed chi-squared distribution. I won't go into the details of what all this means necessarily, but this is going to tell us if what we have found, if this statistic, this number is, if this scenario, if this number indicates a statistically significant difference. And that's based on that value right there. So that's the X value. So I'm going to just click on that cell and pop that in there. They'll hit the comma. And this is asking for the degrees of freedom. Degrees of freedom is simply the number of groups minus 1. And in this case, I have 2 groups, those who enjoyed and those who did not enjoy math. And so 2 minus 1 is 1. So my degrees of freedom in this case is simply 1. I'll close that. And there is my my value. That is my, what we might call the p-value. So that's telling me that this scenario and this statistic is significantly significant. In other words, remember, we want for our p-value to be less than 0.05. So what this is saying is that when we say there's no statistically significant difference in those who enjoy or don't enjoy math, this is saying you only have a 4% chance of being right on this. So it's saying there is actually a significant difference. So when this p-value is less than 0.05, if we flip that around, we can say there's less than a 5% chance of us being correct on this statement. So if we flip that around, we can say, well, there's 95% chance of us being right if we say that there is a difference between those who like and dislike math. So the short of it is that this is a statistically significant finding, and we can go ahead and say, no, I'm going to reject this null hypothesis and say there is a difference between the number of students who enjoy math and those who don't. And so this is our p-value. Now, another way that we can find that p-value, that probability value, is to use this statistic right here. So I'm going to run that one real quick, and I can do this right here without doing all this math and finding that chi-square statistic. Now, I need to find that, but this is just another way to do this if you want to just do it quickly with another set of data. You can do equals, and I'll just do chi-test. And this will simply just take the ranges of the observed data and the expected data, and it'll just give me the p-value. So the observed range is these values right here, and then I'll close that, and then I want the expected range, which is right here, and I'll close up that set and hit enter, and you'll see it gives me the same p-value there. So you could take a set of data and play with it and just run that statistics, that probability statistic, and see if it comes back significant or not before you even start messing with that chi-square statistic. So just another way to run it there. There are the two formulas there that have to do with the chi-square in Google Sheets. Now, let me show you one last thing, and then we'll be done here because this is a pretty quick scenario. I have referred before to a website called Social Science Statistics, and that is www.socsci.statistics.com. I refer to that. I'm going to pop over to that and do the chi-square on that website. And when you when you get to this website, I'm going to just go back to the home page. You're going to come to this screen, and there is a chi-square calculator on this website that does all this in just a couple steps. So if I go to calculators, this is called the chi-square calculator for goodness of fit. I'm going to do another video on these other chi-square calculators, 2x2 and the bigger ones, a 5x5. But this is called just a goodness of fit. This applies when we have just one categorical variable like we did here. We're just measuring one aspect and it has two levels. So that's the goodness of fit test. So I'm going to choose that one over here. And what I'm going to do here is I'm just going to put in my two categories. And I have those who enjoy and those who do not enjoy. They're unenjoying math, if you will. So I put in my two categories. I hit next, and then all I have to do is put in my observed and expected values, and it will do all the work for me. So my observed was 39 for enjoyable, 23 for unenjoyable. So we will just type those in here real quick. And I did this earlier, so those are kind of going to self-populate. Oops, I shouldn't have hit enter. And this was 23. And the expected values, remember, were 31 and 31 because I had 62, and I was guessing that they would be equal in their enjoyment or unenjoyment. So here are my values, and I want a significance level of 0.05, and then I'm going to tell it to calculate the chi-square, and it'll do all that math for me. Here's all the math I did on that Google Sheet. Here it's done it all for me. There's the chi-square stat right there, and it is repeated right down here. It tells us the chi-square stat is 4.129. It tells us the p-value, which is nice, all in one place, and it reminds us that the result is significant. So what I can do is I can take this information, and I am now I'm allowed to more or less conclude that my scenario here that I have been talking about is a scenario that's worth talking about a little bit more, in that we can say, well, there is some difference between students who like and don't like math. And so we might dig into that a little bit deeper. And if we've set up our study right, then we could come out and say, well, these students liked math because of the teacher, or because of the way the math was being taught, or whatever we controlled in that scenario to be able to say why they enjoyed math. And we can say there's the chi-square statistic, but the probability of us being wrong on that is very small. It's less than 5%. So we like that, and we can make some inferences based on those results. So that's just a quick way to run a chi-square, and it's a very simple test, and it deals with a categorical variable, and it's a very nice, clean, simple inferential statistic that can be run for a scenario that fits this type of situation. And there's a couple of different ways to run that.